are going to come in our way. Now, normally what happens in real life scenario, you are in the decision-making process, it's very rare that you have to tackle one objective at a time. In real life, what happens is that instead of one objective to tackle at a time, there are more than one objectives which you need to address simultaneously. Before going into any further details, suppose this is an example here where we are dealing with suppose two objectives. For the sake of simplicity, let us start with two objectives only. Objective 1 and objective 2. Now, finally, when we are trying to get hold of an optimized solution, a good one or a befitting one that we desire to have, then typically what we practice is to go for some weighted, solution out of it. For example, here এটাও কাজ করছে। Now it is working. Thank you. So see here, so there are two objectives, so objective 1 and objective 2, and these are basically weights, normalized weights, 2/3, 1/3. So it's basically a linear combination of two objectives that is going to provide you the final solution. Apparently very simple, but very debatable. The first source of debate is who is going to decide that this type of normalized weight distribution will be appropriate, 2/3 versus 1/3. Why not 1/3 versus 2/3? Why not half versus half? So as a matter of fact, if we think a sort of a convex normalized combination, there are uncountable many combinations. Basically alpha versus 1 minus alpha, where alpha is any proper fraction lying between 0 to 1 that is going to work. Now this is the basic source of your problem, and because of which the question of multi-objective way of tackling or handling the thing that becomes imminent. One thing is for sure that when I am saying that it is 2/3 versus 1/3 distribution of weights, it's very much subjective. So for us, this particular issue is available. I mean, is what is available to us is that this distribution of 2/3 versus 1/3 is rather subjective. In a specific scenario, I think to attach 2/3 weight to objective 1 and this is 1/3 weight to objective 2. Someone else may be thinking otherwise, because to him or her, this higher priority to objective 1 over objective 2 may not be a suitable one. So he or she may be inclined to attach higher probability, higher weightage to objective 2 instead of objective 1. So the scenario may change in that case. Problem is the question of distribution of weights among different objectives, that is essentially subjective. Okay, and because of this subjectivism inherently involved in the scenario, you are in a challenging scenario. Okay, you means in collective sense. So, and a typical problem given in terms of objective 1 and objective 2, attachment of weight or assignment of weight across them may be interpreted by someone in one way, some other else maybe in another way. It is a big, typical tricky issue. Is it all right? Another problem is there. which is even more serious. When we are saying that there are two objectives, objective 1 and objective 2, coming out of two, say, functions, two objective functions, say f1 and f2, we are even, though not explicitly mentioned, we are somehow presuming that objective 1 is not influenced by objective 2 and vice versa. So either of the two objectives, no one is interfering or making any influence on the other. Because it is understood that if that is violated, then the distribution of weight is going to be injured, going to be affected. So this 2/3, 1/3, even if I think that 2/3, 1/3 is a justified one, it is going to suffer from serious questions, because on objective 1 there is influence of objective 2 and vice versa. Which means that so long as objective 1 and objective 2 as two separate objective functions, they are operative independently of one another, life is easy. But unfortunately, in real life scenario, it is not so. Okay, so in typical real life scenario, one objective has somehow, first of all, is intermingled with the other objective, influencing essentially the outcome of other. And even more serious problem